Okay, sorry for the switch in videos there. I had to stop halfway and change rooms. So we'll just continue the question from where we left off. So we already came up with this picture. We recognized that the only information we knew was the highest point was at 2 o'clock at 10 meters. The lowest point is just after 8 at 1.2 meters. And we're interested in the 2 meter mark because we know that that's what's going to happen. You can already see from the graph, you know, we're actually interested more in what happens at 6:30. So right here, right? According to the graph, it looks like we're going to have enough water. But this was just a sketch, right? I don't know if the graph is too high at that point, but it's promising. So what we'll need is to come up with an equation for this blue graph, and then we could either plug in 6:30 and find out how much water we'll have, or we can plug in 2 meters and find out when we'll run out of water. I think it might be easier to do the first. But we've got this graph, we're going to go off and try and solve it. So the first question is, should we do a sine curve or a cosine curve? Well, the problem I've been forcing us using the sine curve in the first few examples, because for me the sine curve is easiest. But in this case, I'm going to have a lot of trouble finding where the sine curve begins. I mean, it's going to happen in the negative hours here, and I don't have an endpoint, and all I have is this max and the min. So I think on this time I'm going to have to maybe use the cosine curve, but let's go off and see. What I do know is I have the max value here and the minimum value here, and that's really all the information I need. So I can figure out the amplitude. The amplitude is going to be the max, which is 10, minus the min, which is 1.2, divided by 2. So obviously that's 8.8 divided by 2, or 4.4 meters. So the maximum is 4.4. So that's good. That can help us. And I could actually draw an imaginary line at 4.4, which is roughly, there's 5, so roughly there. I know there's our amplitude, halfway between the highest and the lowest point. Now we could go off and trace it back and try and figure out what the beginning of the sine curve is, but instead, I think I'm going to find a cosine curve. I've got this much of the cosine curve, and then I'll just continue on until, whenever. If I get half the cosine curve, I know I should be able to figure out the whole thing. So let's figure out the period this time. So again, the period, it's pretty close. These things do sort of happen every 24 hours would be reasonable, or 12 hours, depending on where you're at. So we're going to have to use information to figure out the period here. I don't have the whole period, but I do at least have half it. I know from here to here, I know how long that is. So if I know half the period, then I can figure out the whole period. So to figure out the period, I know this. 8:15 minus 2 o'clock So of course 8:15, I can't, that's not a decimal, this translates to 8 1/4, right? So this is 8 1/4, 8.25 minus 2. So that's 6.25 hours. So 6 1/4 hours, 6 hours, 15 minutes. That's only half of our period. So the entire period is 12.5 hours. That's our full period, 12.5 hours, okay, which is reasonable. They're sort of just a little bit off 12 hours. Okay, so every 12 hours fluctuates between high tide and low tide. It's not exactly 12 hours. In the winter and the spring, in the summer, the tides are a little bit different. That's why we're a little bit off. But in this particular case, they told us that the high tide was 2 o'clock. The low tide is 8:15. And so it's 6 1/4 hours between the high and the low. So our period must be 12.5. So every 12.5, it's going to repeat. Okay, so if 12.5 is our period, we got to figure out our k value. So therefore, 2 pi over k is 12.5. So same math we've been doing all along. 2 pi equals 12.5k. Divide both sides by 12.5, and we get 2 pi divided by 12.5 equals k. Now, I know I don't like decimals with fractions, but it's okay right now. You could multiply the top and the bottom and get 4 pi over 25, but I'm okay to use this. So we've got a k value. Now we're going to try and figure out the phase shift and the vertical translation, and we're going to do that all on our cosine curve this time. So we're going to pretend the cosine curve starts at its max point, doesn't it? So there it is. So our phase shift is right here. The phase shift then must be right 2. Now the difference is the vertical translation. So this is going to be a challenge because this is not the vertical translation. It doesn't move up there because remember the original graph doesn't start at 0. The original graph of the cosine curve actually starts at 1. But this graph, this cosine curve, has been influenced not only by some vertical translation, but it's also been influenced by the amplitude. So I can't use that max point to help me find the vertical translation like I could with sine curves. That's why I like doing sine curves, because I just find the beginning of the sine curve, then I know that that's my vertical translation. But not so in this particular case. So what can I use? Well, I know that this black line will be helpful for this. Now, I think back to when I drew this black line, and I'm not really confident about where I drew it. And you might have noticed it at the beginning of this video that that black line didn't look right. So if you noticed my mistake early on, good for you. At least I'm noticing it now. I said the amplitude was 4.4, so and then I drew this line right at 4.4. That's not right. The amplitude is 4.4. That means the distance between the top and the middle is 4.4. And then the bottom to the middle here is 4.4. That doesn't mean that it's at 4.4. Where is that spot? Well, right here, this is going to be the vertical translation. I'm going to go from the maximum point. The maximum point is 10. If the amplitude is 4.4, then that means it must be at 5.6. I should be able to get it from the low point 2, or the low point, which is 1.2, and I add 4.4, I get 5.6 as well. So I apologize for drawing that line at the wrong spot, but there is 5.6. So there's the actual middle of this graph, and that looks better. Looks more like it's in the middle than my original. It's a big deal because this is what's going to help us describe our vertical translation. Although the original of the cosine curve doesn't start at 0, this imaginary black axis does start at 0. And if that whole axis moves up, then we know that the vertical translation is up 5.6. Okay, so amplitude, highest number between the lowest, subtract the lowest number, divide by 2, 4.4. So the middle point, this middle axis, must be 4.4 down from 10 or up from the 1.2. Either way, it ends at 5.6, and that will tell us the vertical translation. We figured out the period by knowing that we only have half of the period in the picture with 6¼ hours. So the entire period must be 12.5. That translates to a k value of 2 pi over 12.5. And the last thing is it moves right 2. So if I take all this information, shrink it down over here, or move it down a little bit so I have more room, I will get an equation for the height of the tide, 4.4 cos this time, k, which is 2 pi over 12.5 t. It moves right 2, so minus 2. Vertical translation of up 5.6. So that represents our tide curve. And now we can go off and answer the question. Remember, the answer to the question is he wants to exit at 6:30. Will he have enough water? So there's two ways. You could go in and substitute the 2 meters of minimum water and work backwards and figure out when it happens. I think it'll be easier to just plug in at 6:30 and figure out if there's enough water. That's what I'm going to do. So I'm going to take this and I'm going to plug in 6:30. So what's the height going to be? When I plug in 6:30. So 6:30, of course, is 6.5 hours. And then I'll give you a moment to try that, remembering all your steps. 6.5, your first thing you're going to do is subtract 2. Get some number, multiply it by 2, multiply it by pi, divide it by 12.5. Get some decimal. Take the cos of that decimal, cos of the answer. Remember, we're in radians. Get some answer, multiply by 4.4. Get some answer, and add 5.6 at the end. Hopefully you've done this correctly. You get 2.795 meters. Give you a second to check and ask with a neighbor if you haven't quite get that on your calculator. So there's approximately 2.8 meters of water. That's great. I did some math. I figured out 2.8 is this number. Now I got to go off and answer the question. Apparently, he needs at least 2 meters of water at 6.5 hours or 6:30. There's 2.8 meters of water. So therefore, at 6:30, there is 2.8 meters of water. So it is enough for him to sail away. So a really cool question. It's a pretty cool application. I'm able to do that math here. Okay, you could actually ask a really neat question and say, when's the absolute latest time that he could leave? So that would be someplace around here, you know, maybe just a little bit before or just after 7 o'clock, because around 7 o'clock we're approaching that 2 meter mark. I wouldn't want to hold off too long. So around 7 o'clock you're fine. If he misses that 7 o'clock deadline, his boat's going to be on the ground. And then he's going to have to wait until right here. So again, there's a pretty cool question. You know, I don't know, when is that? 9:30ish or so, when there'll be enough water back in the bay or the cape in order to actually leave. Okay. So there's your two questions for today. Lots of video. At the bottom of your worksheet, you see that there's a bunch for you to try. Page 361, number 6, 7, 9, 10, and 13. There is a correction for number 10. The math is a little bit off for number 10. But you've got this. You've got your questions from yesterday. So there's lots of stuff you can practice. And next day we'll take up some of these questions and get you ready for the test. Good luck.